lesson 18 today. We're going to be studying some advanced word problems. And the best way to do it is just to get in there and get our feet wet and learn as we go. So write down this problem so you can see what our variables are. Most of our word problems are going to have two variables, but we're getting some harder ones now, and these are going to have multiple variables. So in this one, we have the number of blues, and then the number of whites, and the number of greens. So we have three variables we have to solve for. The number of blues, the number of whites, and the number of greens. We need to know how many of each color of whatever it is. It could be marbles, it could be checkers, I don't know. But we are going to figure out how many we have of each color. So the number of blues was 4 less than the sum of the whites and the greens. So the sum of the number of whites and the number of greens added together. So there's our first statement. Let's look and see if we can get another equation out of here. Also, the number of greens equaled the sum of the blues and the whites. So the number of greens is equal to the number of blues plus the number of whites. How many of each were there if there were twice as many blues as whites? So the number of blues is equal to 2 times the number of whites. So that's all the statements that I can see from that word problem. So let's put this in some type of sense by seeing what we can substitute. So I see here that I have the number of blues in one term. So I think that's what I'm going to use to substitute here and here. So let's find the number of greens first. So if I can substitute 2 times the number of whites for the number of blues, then the number of greens is equal to 2 times the number of whites plus the number of whites, which is equal to 3 times the number of whites. So the number of greens is equal to 3 times the number of whites. So I can substitute that in here, and I can substitute the number of blues in. So I'm going to move this over and do that. So the number of blues is 2 times the number of whites. So 2 times the number of whites is equal to minus 4 plus the number of whites plus, now for the number of greens, it's 3 times the number of whites. So 3 times the number of whites. So I'm going to solve for the number of whites because I have all the same variable in this equation now, just by looking at this one to solve or to simplify. So what I want to do is get all of the number of whites over here, simply because I already have that right here. So I'm going to subtract the number of whites minus 3 times the number of whites. So that's going to be minus 4 times the number of whites, because this is 1, negative 1, negative 3. So that's going to be a negative 2 times the number of whites is equal to negative 4. So if I divide both sides by negative 2, I find that the number of whites is 2. Not so difficult. So now that I have the number of whites, I can figure out the number of blues. So that's going to equal 2 times 2, so that's 4. So the number of blues is 4. And now I could find the number of greens because 3 times the number of whites is the number of greens, and there's 2 whites, so 3 times 2, that's 6. That equals 6. So that wasn't really super difficult. We were able to substitute all the variables to the same variable and then solve once we figured out a value. So the number of blues is 4, the number of whites is 2, and the number of greens is 6. And I'm going to check my book because I'm not on that same page. And let's see, and I think I can show you guys. Yes, so here we have the copy of the book. And if we scroll down, we can see the number of whites is 2, the number of blues is 4, and the number of greens is 6. So let's look at, I'm going to clear this page. And we'll look at the next example problem. And I'm just going to screenshot it like I did the first one because that seems to work really well. And I can just drag it in. And it's just a whole lot faster than me trying to type and you trying to decipher my handwriting. So the quarters, nickels, and dimes total 20. So we know how to write that. Number of quarters plus the number of nickels plus the number of dimes is equal to 20. Their value was $1.90. So 25 times the number of quarters plus 5 times the number of nickels plus 10 times the number of dimes was equal to $1.90. How many of each kind were there? If there were 4 times as many nickels as quarters. So the number of nickels was equal to 4 times the number of quarters. So I see already that I could substitute in a value for NN using the number of quarters. So I'm going to do that here. So the number of quarters plus 4 times the number of quarters plus the number of dimes was equal to 20. So 5 times the number of quarters plus the number of dimes is equal to 20. That's as far as I can go with that because I can't substitute for quarters or dimes. So now let's do the same thing here. I'm going to substitute 4 times the number of quarters for the number of nickels in this statement. So 25 times the number of quarters plus 5 times 4 times the number of quarters plus 10 times the number of dimes is equal to $1.90. So this becomes 20 times the number of quarters. 25 and 20, that's going to be 45 times the number of quarters plus 10 times the number of dimes is equal to $1.90. Well, now I have some substitution that I can do. I'm going to, or not some substitution, but elimination. I'm going to multiply this by a negative 9. Negative 9 times 5 number of quarters is going to be a negative 45 times the number of quarters. This is going to be negative 9 times the number of dimes, and this is going to be a negative 180 because negative 9 times 20 is 180. Now I can eliminate the number of quarters, and 10 minus 9 is 1, so the number of dimes is equal to 10. So out of the number of quarters, number of nickels, and number of dimes, I have found that there are 10 dimes. So now I'm going to see if I can't substitute that in for one of these statements that I made right here. So I have 5 times the number of quarters plus the number of dimes is equal to 20. Well, if there are 10 dimes, then 5 times the number of quarters plus 10 is equal to 20. When I subtract 10 from both sides, I get 5 times the number of quarters is equal to 10. So when I divide by 2, or by 5, I find that the number of quarters is 2. There are 2 quarters. And now that I know how many quarters there are, I can find the number of nickels by just substituting in. So this would become 2. 4 times 2, the number of nickels is equal to 8. And if we scroll over here to our book, we can see that we did that correctly. We had 8 nickels, 10 dimes, 2 quarters. So let me clear the page. And I'm going to take the next problem. And this is one of those varies directly, varies inversely problems. We did these in the spring as well. Let's look at that. All right, reds varied directly as blues squared and inversely as greens. So there's my ratio. When there were 80 reds, there were 4 blues and 2 greens. So 4 times 4 is 16. 16 divided by 2 is 8. So 80 is equal to 8 times the constant. When I divide both sides by 8, I find that the constant is equal to 10. So how many reds were there when there were, because the 10 is my constant, 8 blues and 10 greens? So 10 over 10 cancels. So there were 64 reds. Easy peasy. That one was pretty straightforward. That one didn't take a whole lot of brain power on my part. I don't know about you guys. So let's clear the page. Let's double check our answer. Let's make sure I'm right. Yes, there were 64. So awesome. We got that right. So let's look at this next problem here. Pull that in and solve it so we understand what's going on. All right, the sum of the digits of a two-digit counting number is 5. So the digits are the tens place and the units place, right? But the sum of those digits is equal to 5. When the digits are reversed, meaning their value is reversed, so the tens place is a 1's value and the units number has a 10 place value. When the digits are reversed, the number is 9 greater than the original number, and the original number would be 10 times the tens place plus 1 times the units place. So what was the original number? So first thing we have to do is get all of our variables on one side. So we are going to say, we're going to subtract 10t and u from both sides. So minus 10t minus u. So that's negative 9t plus 9u is equal to 9 because these canceled out. Now what I need to do is simplify this or reduce it. So I'm going to divide everything by negative 9 because that's my lead coefficient right here. So that becomes 1t minus u, because then that becomes a negative 1, is equal to negative 1. So t minus u is equal to negative 1. So now to solve for t, I say plus u to both sides. So t is equal to u plus 1. So now I can use this to substitute into this original equation. T is u plus 1 plus u is equal to 5. So this was that substitution value. So if I subtract 1 from both sides and add these u's together, I get that, I'm sorry, I did that wrong. This should be minus 1, minus 1. Leave my minus sign here. Okay, so I'm going to add 1 to both sides and combine the two u's. So that's going to be 2u is equal to 6. U is equal to 3. So now that I know u is equal to 3, I can bring that up here. T plus u is equal to 5. T plus 3 is equal to 5. Subtract 3 from both sides. T is equal to 2. So my original number was 23 because t was the tens place and u was the 3 was the units place. So that would be my answer. So we can double check. And there it is. The original number was 23. So we did that right. Let's look at example 18.5. Bring that in here. All right, example 18.5. To get 1,000 gallons of a mixture that was 56% alcohol, it was necessary to mix a quantity of 20% alcohol solution with a quantity of 80% alcohol solution. How much of each was required? So we have our, we decide to make a statement about the alcohol first. So we have the alcohol 1 plus the alcohol 2. All right, and when we added that together, we get the alcohol total. Make sense so far? This is 20% plus 80% to get the total percent that we have. Okay, now we're going to use parenthesis as mixture containers. So we're going to put parenthesis here, and we're going to put them with the right operators in here. So this is what we know we need to do. We have to add the two mixtures together to get the final result. So this is going to be, let's pour in the first solution and dump in the second solution. So Pn is the first mixture, and Dn is the second mixture, for a total of 1,000 gallons. That's what we're looking for right here. To get 1,000 gallons, we add 20% and 80% to get the 56%. So now we're going to put those percentages on each one of these. So we get 20% would be 0.2 when we put it in a decimal form, times the Pn, plus this one is 80%, so this is 0.8 times the amount we dumped in, and that's going to equal the total percent, which was 56, so that's 0.56 times the final amount we wanted, which was 1,000. So now we have to figure out this. All right, so now we have we have the original unknown, and now we have the percentage unknown, and we're going to use that to substitute. So I'm going to figure out what I can substitute for Pn. So for Pn, I can take Pn plus Dn equals 1,000, which is this one right here, and I could subtract Dn from both sides. So Pn is equal 1,000 minus the amount we dumped in. Okay, so that's what I can substitute n for this and for this. So 0.2 times the amount poured in, which is 1,000 minus Dn, plus 80% times the amount that was dumped in, is equal to 0.56 times 1,000. Okay, which if I go ahead and do the math here, I know that's going to be 560 because we moved the decimal place twice, so that'd be 560. All right, now we can eliminate decimals by multiplying by 10. So times 10. 10 times this is going to be 20. 20 times 1,000 minus Dn plus 80 times Dn equals 560. Oh no. I multiplied times 100, not times 10. That's why you should always write it down so you know what you're doing. I'm multiplying everything times 10 to get rid of the decimals. So 10 times that would be 2 times 1,000 minus dn plus 8 times dn is equal to 5,600. All right, now that makes sense. Now I can multiply. 2 times 1,000 is 2,000. 2 times dn plus 8 times dn equals 5,600. If I take that from here and I combine those, I get 6 times the amount dumped in is equal to 3,600. So I divide both of those by 6, and the amount that was dumped in was 600. So 600 is the amount, 600 gallons of the 80% solution is what was mixed in. And since we have 1,000 gallons total, if this was what was dumped in, this is the 80% solution, 600 gallons of that. It's 1,000 gallons total. So then I know that the 20% solution that was poured in had to be 400 gallons because the amount poured plus the amount dumped was 1,000. And 1,000 minus 600 is 400. All right, that one was a little bit of a thought provoker. You got to kind of, that's why it helps to write this out first so you can kind of visualize what's going on and then start breaking it down into steps. Okay, let's clear the page. Let me double check my answer while I'm looking at it. Let's scroll down here and see. Yes, so we were right. So we had 600 gallons of the 80% alcohol. And since the total was 1,000 gallons, we would need 400 of the 20% alcohol. So that was correct. So we did good. So let me clear this. And we'll go over here. And we're going to capture this one. It's a similar problem with percentages and liquids. Okay, so how many liters of a 64% glycol solution must be added to 77 liters of a 23% glycol solution to get a 42% glycol solution? So this isn't a similar one, but we're already given certain information. So for instance, how many liters of this glycol solution, this glycol 1, that's this, must be added to 77 liters. Actually, no, we're going to add this to this. So this is the original amount. This is the 77 liters. We're going to put the amount added here. And then that's going to equal the final number or the total, whatever you want to put right there. So the original amount that we started with, glycol 1, that's going to be 77 liters right there. And we don't know how much we have to pour in, so we're going to call that PN. And then the final is just going to be 77 plus PN. But now we need to put in the percentage of each of these solutions, right? So the percentage of this solution is 23%. So 0.23 times 77 plus, this is the 64%, so 0.64 times the amount we pour in. And then we want a 42% solution in the final number, so that's going to be 0.42 times 77 plus PN. All right, so there is what we have to solve. So now we're just going to do the mathematics, and this is going to be 17.71 when I multiply, plus 0.64 PN equals 32.34 plus 0.42 PN. All right, so now I am going to go ahead and subtract 0.42 PN from this side and from this side. This would cancel. And then I'm going to subtract 17.71 from both sides. That would cancel. So what I'm left with is 0.22 times the amount poured in is equal to 14.63. So now if I divide both sides by 0.22, the amount poured in is going to be 66.5, and that's in liters. So that answers the question. How many liters of this 64% solution has to be added to get the 42% solution? So that's what we did, and we solved the problem. So let me check. Let's see if we got there. Yes, 66.5 liters whenever we finish that. Awesome. So we can clear this page. And I'm going to pull up the final, because here's our problem set starting. This is the final problem. We're going to pull that in, 18.7. This is one of those. I like these. These are kind of fun. It's just a component chart. So the weight of the carbon in the container of whatever this is was 113 grams. What was the total weight of the compound? And then it tells us that C is equal to 12, H is equal to 1, and Cl is 35. So the first thing we do is a ratio problem. And the gram atomic weights are given in the parentheses for us, so we just have to figure out the ratio versus 113 grams of this. So we have C3 and H7 and Cl. All right, so carbon is C, that's going to be 12, and we have 3 of them. So times 3, that equals 36. Hydrogen is 1, and that's times 7, because that's the number here. That's going to be 7 there. And then Cl is 35, and there's only one of those. So times 1 is 35. And now we add all that together, and we get, that's 12, that's 18, carry the 1, that's 78 grams. That's the atomic weight for this right here. So the amount that was in the container, the weight of the carbon in the container, was 113 grams. What was the total weight of the compound? So we know that we have 36 out of 78, right, is the ratio of the carbon to the compound. So 36 over 78 is going to equal 113 over some number, the total. So we just cross multiply. 36 times x is equal to 78 times 113. So let me get my calculator. I can't do that in my head. My brain's not quite there. 78 times 113 is equal to 8814. So 8814. And then we're going to divide that by 36. And that is going to be, we're going to round that to 3. So 244.83. 244.83. And I've written that on the wrong side. That should be over here. That is the value of X. That is the number of grams in the container that we had. That would be our total. All right, and that is all we have for lesson 18. Watch out for those more complex word problems. Just kind of break them down as you can. Look for the keywords. Look for the different ways to do those. If you have questions, feel free to ask. And that's all I have for you in 18. I will see you in 19.